Good morning and welcome to the next presentation. And this presentation is about putting AI into practice. We've got three presentations coming up here. And the first one is Matloob from University of Sydney and also University of Suffolk. So Matloob, over to you to give your presentation. Thank you.
Thanks, Adam. Hello, everybody. I'm Matloob Khushi. And I thank everybody and coming to my talk and providing me this opportunity to talk today. So I'm going to talk about AI, the fourth age. So what do I mean by the fourth age? We've seen three ages when we know about the Stone Ages and the Brown Age and the Iron Age, and how these different ages, these era has transformed the human life. People have changed their way of working, their way of interacting with each other. So the whole society being transformed. And this century, which I would like to call it as a fourth age, we've seen that how AI has already been transforming our life. Just 50 years ago, talking to somebody, doing a video call over the other part of the world is a science fiction, is a fantasy. And now we're doing it on everyday basis. Even this seminar, this session is running online across different part of the world. So in this fourth age, which probably I would like to say that is just started to happen during the 21st century, we can now put together the hundreds and thousands of years of human knowledge onto the microchip and then get that microchip to make the decisions such as the human do. And we have recently seen that the AI is surpassing the human intelligence. So what's my contribution in this domain? So I also work on AI basic research, developing new methodology and new algorithms, and also some applied domain. So in this example, the AI basic research, what we have recently done, that all the AI algorithms learn from the data. And in real world, we've seen that these data sets are imbalanced. So what do we mean by that? That one class is have a lot more samples, a lot more examples, whereas the other class has less examples. So here's an example of a data set that I received from ovarian cancer data sets from PLCO Cancer Bank US, and we can see there are nearly 38,000 normal people, which we call negative people, and 277 patients in this group. So now if we train any AI algorithm on this data set, so it's very likely that this AI algorithm going to predict every person coming into the clinic as a normal person, as a negative class. It's gonna definitely bias towards that. So what's the practice in an AI industry? So there are there are a lot of methods actually, but two are the main one which people use to address this problem, is that randomly sample data out of these 38,000 roughly people and match it to the smaller class, 277. So now you got similar data sets from two different type of classes, and then you train your algorithm. So we could already see there's a big problem here. We're throwing away a lot of data, which could have a very good some example, a lot of information there. We're wasting our data. So another commonly used practice is basically oversample this smaller class to match to this bigger class, and that's been done regularly. And there are a lot of methods out there which addresses this problem, and they all work on the continuous data. What do we mean by the continuous features is such as age, where you could have a continuous number, or you could your BMI or your salary, income, that kind of thing. But in realistic data set, such as these cancer data set and many other data sets, they also have nominal features. So what do we mean by nominal features? Like gender, that could be male or female, or your marital status, that could be like a single, married, never married, divorced, that kind of thing. So how do we oversample? How do we address that problem? For that problem, we only have one method, which is called smooth NC. So we have developed another novel method to even improve what's been already done, smooth NC. And working on these 4 data sets, we can show that our method can outperform this existing method on 3 famous metrics: precision, recall, and F1 score. And our method can even work on that type of data set which only have the nominal feature, such as this card data set, where we only have a nominal feature, there's no continuous feature. So there's no other method exists that could address this kind of problem. So we addressed it, and now this method could be implemented on this kind of data sets. So another interesting problem that I've been working lately on developing a watch that could measure your continuous blood pressure using 2 ppg signals. We precisely measure the time it takes from blood from going from this point to another point. So this is our preliminary data collections, ethics approved, the work is underway, and we could already see some good results. So why we're measuring continuous blood pressure is an obvious thing, being heavily correlated with many other diseases, causes many hospital admissions. So we already showed that in our last year publication that our method outperforms some of the existing methods in this domain. Now we're collecting the data on real patients, and we hopefully to develop world's first AI-based watch that could measure the continuous blood pressure. So I also work on financial domains where we model the financial markets and predict what's going to happen next. We predict the Forex prices. And in this paper late last year, we showed that we can stack together a bunch of famous methods such as RNN, LSTM, ARIMA, and then we can focus the product price and predict the error rather than the price. If we stack them together, we can do a very nice prediction. And similarly, in another paper, we can show is just not enough to just to predict the price. We also need to look at the portfolio. We also need to make sure that we're not taking too much risk. So that's where we address the Sterling ratio and Sharpe ratio to maximize the portfolio risk. And we can show that we can combine some technical indicator, bunch of trading rules, and on the top of that, applying some genetic algorithm can give very good results. We can even get up to 320% annualized profit. So thank you very much for listening.
Brilliant. Thank you very much indeed. Yeah, so thanks for that, Matloob. I've got, we've always got some time for questions now. I've got a number of questions I'd like to ask. So really interesting presentation, great way of you know, getting the minds thinking about this subject so early in the morning. But let's start off with one question about us and humans and AI. So do you think that AI will take over human jobs? What's your view on that?
Yeah, it's been commonly been considered that AI is becoming a lot more popular and is doing a lot of things that human can do. So will there be a threat to the human jobs? Will there be less number of jobs in future? But I don't think so. It's just a shift of skills that we need from the people. You know, when we've seen .com era. We've seen the people, how they were used to be very concerned about the computer taking over a lot of different jobs, but we've seen that in the history, there's just a shift of skills, new type of jobs will emerge, and new type of opportunities come into the market. And recently we've seen there's an exponential growth on the demand for the data scientists. So it's just a shift of skills and the people that we need in the future.
Yeah, I guess taking your point about us doing this via video, you know, in the past we've obviously been physically in one space, you know, or things have been shipped by post, you know, so things change and that immediacy can be helped somewhat. So looking at you talked about your oversampling method. So I just want to ask a question on that. So what type of data sets can benefit from your oversample method?
Yeah, as there are a lot of methods out there that exist which address the continuous data, where we have a continuous stream of numbers, such as, you know, you capturing age of the person participating in a study. So that's a kind of continuous feature. So there are already methods out there, so many methods out there. But we in the AI field, we only had one AI method that was addressing the nominal features. So any data set that have a nominal features or categorical features, such as the gender, male, female, or your marital status. So that kind of, wherever you have that kind of features in your data set, our method will learn that kind of data set very well.
So the next one's around kind of bias, and we've seen this with some of the things around ethnicity and bias, and so it's about skin color. So do you think the skin color or how tight someone wears your blood pressure measuring watch will have any effect on the readings?
Yes, I think there will be a little bit biases towards the skin, but we addressing the skin color is easy to address because you can automatically learn that, but the pressure is a difficult one. So so we've observed that having a different pressure, how tight somebody wears a watch can change the data dramatically. So to address that now, we have put another sensor on top, like built into the watch, that measures the pressure, that how tight is somebody during the watch. So that will adjust that effect. Hopefully we'll be able to address that.
Good. Okay. Nice. That's been thought of. So on the trading side, talking about the financial side, so moving away from the physicality to some of the trading side. So do you think your forex price prediction methods could be implemented in trading? Do you think that those could be used in a trading scenario?
Yeah, the first paper that I showed you, where we're just predicting the price and getting close to what happens in the future, it's not very, it can't be really implemented straight into the market. We need to take into account the trading cost, the commissions, the slippage, a lot of things. So that's what we have addressed in our next paper, where we also look after the overall portfolio things. So it's just predicting the price is not really enough. If you want to make an automatic robotic type things, then you need to take into account a lot of other things, which we are addressing and working on improving upon that thing.
Okay. Perfect. So we've got just over 2 minutes left on here. So, and this is kind of a bit of a big question. So let me see if I can get your answer on this. So, what do you think is the biggest challenge of making an autonomous trading bot? What's the biggest challenge we've got for that?
Yeah, that realistically, even the commission is not a big thing. You can account for that. You can do the slippage. You can take into account a little bit of slippage as well. But the major thing, which is very difficult to take into account, when you're doing your learning from historical data, you're not taking into account that when you put that AI method into the practice. So whenever somebody do a trade, so you're now both going into this trading system. So you're changing the dynamics of the market. So that kind of thing is very hard to take into account. So every dollar that goes into the market or come out of the market, that change the dynamics, isn't it? So that means when you're just doing the learning from the historical data, you're not taking into account that. So but when you do that realistically, so if you're bought buy something for $1 million, for example, so you've now changed the dynamics of the market. So we haven't taken that thing accounted during our learning or our designing of an algorithm, and that could have a ripple effect. You bought something, so other people will counteract it. Either the price continue to go up, or there could be an adjustment effect if you buy a lot. So people now think, oh, this thing has gone overpriced, so people will start selling it. So that that kind of thing, taking into account practically, is difficult challenge.
Yeah, and I guess as well with trade as well, it's the immediacy of the trade. Those milliseconds really make a difference. So, actually, trade is one thing, but that immediacy and getting things down as a short trade cycle as possible. Brilliant. Thank you very much indeed. We're out of time. Brilliant presentation. So next, I'd like to hand over to Adnane from the University of Suffolk, who's going to give a talk about applications of natural language processing. So thanks very much, and Adnane, over to you now. Thank you.
Hello everyone, my name is Adnane Ez-zizi. I'm a lecturer in artificial intelligence and data science at the University of Suffolk. In this presentation, I'll be talking about natural language processing, or NLP in short. First, I'll broadly define what it is and why it's interesting to build NLP-based products. Secondly, we will discuss a few categories of NLP applications in the business world. And finally, we will dive a little bit in an example of an NLP project that I worked on recently, just to give you a better idea about what's involved when building NLP pipelines. So what's natural language processing? In NLP, we are interested in building programs that has a language component either in the input or the output. The purest form of NLP programs used to have language in both sides, the input and output, but now the most interesting programs are able to accept multimodal data as well. So you could have a program that takes in text or speech data, then output text or speech, or you could have input images or videos, and you could also output labels like whether an email is spam or not. One of the most interesting aspects about NLP is that it's multidisciplinary. So while NLP is considered as a sub-branch of computer science and linguistics, many of its ideas comes from mathematics and psychology. My personal background is mostly in maths. I also have a PhD in psychology. And during the last 3 years, I had the chance to work a lot with linguists. And I can tell you, it really helps to tackle NLP problems from these 4 angles. Okay, so why should you care about NLP products? Well, it's a very profitable business that's growing rapidly year on year. So for example, in the last 4 years, since 2017, the minimum yearly growth was estimated at about 42%. This growth goes hand in hand with the also increase in research in the topic, which is reflected, for example, in a huge increase in the number of papers and conference presentations submitted each year. So the timing is perfect. We have a huge market, data is omnipresent, the computing power is there, and we also have very promising results coming from research labs. Okay, let's talk now about some axes of applications. Most of us now use NLP multiple times a day without even thinking about it. So now application works so well that they disappear in the background. One of these axes of application is text classification. For example, automatically identifying email spams and removing them from your inbox, or detecting the sentiment of tweets or customer reviews. You could now ask questions like, does this tweet include hate speech, or does it give information about the occurrence of a disaster in some part of the world, and so on and so forth. Dialogue systems constitute another big vertical in NLP applications. That includes things like voice assistants like Siri or Alexa, as well as chatbots to answer customer inquiries. Or you have also information extraction. So for example, you can have NLP programs that can extract key information for you from large pile of text data. And I'm sure you have heard about the recent fraud investigations against one of the largest manufacturers of airplanes. So the investigators were able to examine more than 60 million documents to prove their wrongdoing by using NLP techniques. Another category is text summarization, where you take a set of text documents and try to reduce them to a small summary of key facts. And there are, of course, many other applications like machine translation, but we won't talk about here. Okay, let's look at the research project that I worked on recently, just to give you a taste of how an NLP pipeline works. So the main question we wanted to answer in this project is whether we can predict English tense from context alone. What do I mean by that? So suppose we have a sentence like, John is currently learning Polish. So the tense in this case is present progressive, coming from the verb form is learning, and the input is all words surrounding the verb as shown here. And we added to that the verb infinitive. This problem could be categorized as text classification because you have some text input, so the words surrounding the verb form in a sentence in this case, and we want to select a tense label among 12 possible tenses. Actually, we only consider 11 tenses because one of the tenses is used very rarely in practice. To answer this question, we use data extracted from a large corpus that contains about 100 million words. And from this data set, we extracted all possible sentences. Usually in NLP task, you have to do a lot of data pre-processing steps, which include things like removing punctuations and other non-allowed characters. In this task, we also needed to tag the verb forms for their tense. And for that, we used some heuristics, combined, of course, with the help from linguists. We managed to do pretty well and got a tag at the end that could achieve an accuracy above 96%. Another important element for us was to understand the choices of our model. So for that, we used a natural language learning model that is explainable and mimic how humans learn language. And if you want to learn more about this model, I left a link to the Python package, our Python package at the bottom of the page. So typical steps in simulating a model in an NLP task include selecting good model parameters, running the model with the chosen parameters, and testing the model on unseen data. And this is, of course, shared with other machine learning like pipelines. Of course, there is also the step of model deployment that you usually have in a business setting, but it wasn't our aim here. In terms of results, they were quite good with 68% accuracy in comparison with 9% only if you go completely random on the predictions. Most interestingly for us, from the model, we could extract the expression that are the most predictive of each tense, so that when you see them in a sentence, you know you are likely to have to use a certain tense. So for example, you can see that verbs that report speech like reply, nod, or smile are predictive of past simple. Adverbials like since then, already, or never for present perfect, and tomorrow or hopefully for the future simple. The key thing I want to highlight here is not the results per se, but the methodology, which I think can be used in many other settings as well. And in general, having explainable models is really important, and people now realize the importance of this more and more in the field of AI in general, especially if AI is applied to areas like healthcare, justice, or banking, and so on. Okay, I'll leave you with some extra information about the project, and thank you for your attention.
Great, thanks very much, Adnane. Thanks for that presentation. So I've now got a few questions for you. So we've got about 5 minutes on this. So let's just kind of look at some of the key points. So in your slide where you talked about you showed the top predictive expressions, couldn't you just extract them simply using frequencies? Why would you need a model to do that?
Thank you for your question, Adam. Well, I would say like you can use, the short answer would be no, if you use like raw frequencies, because you have, for example, articles like the or a, which are very frequent in general. So if you just take raw frequencies, they will be important or predictive for every tense. So you could say, well, we can use, for example, frequencies relative to other expressions. So that's a bit better, but I would say it doesn't take into account like complex group dynamics like in your language system. So for example, if you have, I try to keep it simple. So if you have, for example, an expression A and expression B that occurred in an instance with a certain tense, so it perhaps like expression A, let's say, can block like the occurrence of a certain tense. It's not because it didn't occur with the expression B that it won't occur. So you count it as non-occurrence, but it's just because expression A blocked that. So this kind of complex dynamics won't be taken into account if you use just frequencies. So and think about it, if you have used like statistical methods, when you're studying like the effect of variables, you want to partial out the effect of other variables. So you take everything into account, and these things can't be computed with just frequency. So that's why
Okay.
using the model is useful.
Brilliant. All right, so let's take another angle as well. So are there practical settings where your methodology of extracting the most predictive expressions could be applied?
You could, so one advantage of this, of course, as I highlighted in the talk, is that it increased the explainability of your model, so you could easily interpret your results. So by having like those top expression, you know that you can have, or you expect to have a certain outcome. So this is one thing. The other thing, it could be useful, for example, in application where you need to check like a large set of documents. Let's say in settings where you have job applicants that send like their CVs or cover letters, so you don't want to read everything. So the model could highlight like important sentences for you, and then the one check-in will just read those expressions and decide whether to accept or reject that application. And if they decide to read it more carefully, then that's it. But at least they can filter out like a lot of work by doing this. So that's one application.
Perfect, brilliant. So what do you think is the most difficult part of an NLP pipeline?
So definitely, I would say like the fact that you have to deal with unstructured data. So you have to do a lot of pre-processing. Like the data is usually like messy, so you have words misspelled, for example. So you have to be careful. And we have a saying in computer science that says garbage in, garbage out. So you have to have good data to expect like good output as well. So a lot of work goes into preparing the data and making sure that your data is clean. And especially if you are working with linguists, like they love the language, so they'll get upset if you don't have don't have like clean data.
Okay, so I'm going to challenge you on this. In 15 seconds, what are some of the most exciting current directions in NLP?
Wow. So for me personally, it's all everything like that's related to education. So having support system like chatbots that will be with students as they learn online. So can work as decision support as well. So suggestion, for example.
And that was your 15 seconds.
Yeah, sure.
That was your 15 seconds. You see, that's a challenge. You see, it's just so difficult to get these things. Brilliant. Thank you very much indeed. Really good presentation. Sorry to cut you off there, but we've got so much to get through today. So I'm now going to hand over to Nicholas from the University of Suffolk, who's going to talk about putting AI into practice. So Nicholas, over to you. Thank you very much.
Hi. My name is Nicholas Caldwell. I'm Professor of Information Systems Engineering at the University of Suffolk. I've been involved in artificial intelligence research since the mid-1990s. Back then, it was all about designing expert systems and linking them to this newfangled thing known as the World Wide Web. Today, I'm going to give you a taster of some of the projects I'm currently working on. I'll warn you now, they're all very early stages. First project is with Matrixx software. They're an international digital commerce platform company that provides support to international telecoms corporations. This project was initially funded as a knowledge transfer partnership project through Innovate UK, but is currently on hiatus due to COVID issues. Matrixx's problem is a testing one. Any reasonably complicated application will suffer an explosion of paths through its code, the cyclomatic complexity measure. This gets worse, of course, when your application is GUI driven. Now, human users frequently will find a happy path through your software, but sometimes things go wrong. They hit the wrong button, they back up, they put in the wrong input, and if you're unlucky, they crash your app. Now, that's not a good thing in general, and it's certainly not a good thing when your software is supporting potentially millions of users. Obviously, you can do manual testing, but manual testers will frequently lose the will to live when they've been doing regression testing for far too long. Our solution then has been to seek to automate this process. Our KTP associate, Anisette, worked very hard to develop a prototype which utilized open source software to explore the app space, to log the messages that were received from instrumenting an application, and to capture screenshots. You can get a sense on the slide of a very basic test app and already the explosion of paths that this can generate. We then followed this up by feeding the screenshots into a machine learning algorithm and made some progress in classifying images according to whether it was normal behavior or we had some form of crash behavior, such as a pop-up error message. We've got lots more work involved in this to get this to a full-blown automated testing regime, but it looks very promising at the moment. The second project is with Coderus. Coderus, who are headquartered at Adastral Park, provide software and app development services to a whole range of companies, from small startups and SMEs to FTSE 100 and Fortune 500 companies. Our project with Coderus is again an Innovate UK knowledge transfer partnership, and our very hardworking KTP associate on the project is Pranavi Vasa. Now, software has moved into a space where it is increasingly about choosing components, choosing libraries, making use of other people's APIs. And this is true in AI development. Think how many libraries that you use in any AI solutions that you have been developing, but it's true in app development more generally. Indeed, to the extent that our government has put standards out for organizations within government to use when defining APIs for others to make use of. Also, if we look over to Google, the MAD score is a recognition by Google that they would like to improve the use of modern application development techniques in apps designed for their ecosystem. We have anecdotal evidence that suggests that software developers don't always make completely rational choices when it comes to the components and the libraries that they use in building their software. Suboptimal choices will lead to suboptimal code. So this KTP is part of an effort by Coderus to improve the development of software by making sure that at all times they are choosing the right components, the right libraries, and embedding that know-how of how to choose the right libraries, the right components into their automated build tools. So our solution here is using machine learning on technical documentation to identify those best elements. Again, this is a project where there's a lot more to be done, and it's currently heavily company confidential, so I can't really say any more at this time. Our third project is with Suffolk Libraries. Now, at one level, Suffolk Libraries is an organisation responsible for a network of 44 branch libraries across the county of Suffolk. At another level, they're a charity that support children's literacy, vulnerable people, and promote well-being across the entirety of Suffolk. And you can even borrow books from them, and videos, and ebooks, and a heck of a lot of other things as well. This is a Keep Plus project funded by the European Regional Development Fund, and working on this are two of my colleagues, Dr. Sarah Richards and Dr. Abby Millett from the School of Social Sciences and Humanities. And on the software side, I have one of my final year software engineer apprentices, Nathan Dixon, helping out with the design and build of some very useful software. At least we hope it will be. Now, to give some context to this problem, to be happy, to be healthy, people need various needs met. Our partner, Suffolk Mind, has come up with a emotional needs and resources audit, and you can see some of the needs identified on this on the slide. And these range from the purely physical, like food and drink, sleep, movement, to more emotional needs such as meaning and purpose, privacy, security, control. Now, we believe that these needs can be met through various activities and making use of various resources. Over the course of a normal year, Suffolk Libraries puts on almost 20,000 activities across the county in its various branches. And we have a belief that libraries generally can provide the opportunities for individuals to meet these needs, and also the resources to help people to meet the needs themselves. So the Discover More project with Suffolk Libraries is essentially about building an application, a lifestyle and well-being app that has at its heart some form of AI recommendation engine. And we're working on a way of matching an individual's unmet needs to relevant activities and taking this match in consideration of various constraints, such as an individual's interests, their geographical location, and any constraints on their access to activities. With thousands of activities and even more resources, it's obviously not a sensible thing to consider manually tagging all of these activities to one or more of the 12 needs. It just will not scale. So we're looking at heuristics and NLP rules that will allow us to tag activities to the needs in an automated fashion. If we can get this to work through strictly NLP techniques, that will be great. If not, we are prepared to go further and deeper into, say, reinforcement learning and whatever it takes to get this to work. And for a final project, one on COVID-19, this is a project led by Mahesh Praladhan of Ipswich Hospital and two of my colleagues from Life Sciences, Dr. Aida Rajic and Dr. Federica Bazzieri, funded by Ipswich and Colchester Hospital Charity. Now, if we're to win the war against COVID-19, we need to have a better understanding of this really nasty virus. So a little bit of medical context. On the slides below, you can see various cells from blood samples. The ones stained in purple are white blood cells or lymphocytes. There have been some studies that have indicated that a reduction in the number of white blood cells, known as lymphopenia, is a characteristic of patients who have COVID-19. Worse, it's a potential marker for a poor prognosis in younger patients, increased likelihood that such patients may end up sadly requiring ventilator treatment. So Mahesh and my life science colleagues have been glaring at blood samples and looking to see what they can find out in those samples. And in looking to see if there are morphological markers showing that there's a difference between the blood of those with COVID and those without. So morphological markers in this case could be the size and the shape of the lymphocytes, the shape and the ratio of the cytoplasm. So if you're looking at the micrographs, the cytoplasm here is the paler purple halo, if you like, around the nucleus. And of course, things are happening inside the nucleus itself, which is probably a bit too difficult to make out in the resolution of the micrographs on screen. If Mahesh, his colleagues, and Aida and Federica can indeed identify some appropriate morphological markers, then we'll be attempting to build a combined image analysis and computer vision solution to automate the process of identifying what goes where in terms of whose blood might be indicative of COVID-19 infection or not. And to give you a sense of how difficult this could be, if we look at the micrographs on the bottom, we'll see that the leftmost micrograph is of someone who is well, so a normal lymphocyte. The second leftmost is of a patient who is unwell, but they don't have COVID. The remaining two micrographs are patients who are unwell and sadly have contracted COVID. Again, working very hard to see whether what we can see in the blood samples is genuinely appearing across multiple samples before we head into the depths of producing an automated solution for this. Finally, I'd like to make some acknowledgements to our partners here: Matrixx Software, Coderus, Suffolk Libraries, and the East Suffolk North Essex Foundation Trust. And of course, our funders, Innovate UK European Regional Development Fund, and Ipswich and Colchester Hospital Charity. Thank you for listening.
Brilliant. Thanks, Nicholas. Really good presentation and a great way to end off these 3 presentations. So I've got a few questions for you, if that's okay. And we've got about 5 minutes. And I just want to tease out the benefits of your research to the SME market, because I think this is really applicable to them. So we'll cover some wider area, but I just want to start with the SME market. So tell me, what do you think of the funding opportunities available to SMEs?
Probably the best funding opportunities are the knowledge transfer partnerships and their smaller variety, the mini KTPs. So these give you access to an academic at 10% of their time, so half a day a week, and the opportunity to employ, and if you're an SME, with the government funding 2/3 of the salary, a postgrad or a postdoc to actually do real work for you for 12 months, 2 years, 30 months, whatever the length of your KTP. So this is a fantastic opportunity to get really good work done for a company, and potentially an opportunity for you to have the longest job interview in history.
Yeah, I get that. And in fact, my first time actually working for BT was part of a sponsored student, and that was 34 years ago. So it's been a long interview for me within BT as well. And actually, just on those KTNs, we see great benefit through those. We work very closely with them. So, but for the funding opportunities, do we need to be doing original AI research? How's that work?
Nope. For a KTP or mini KTP, the project needs to be original to the company. It doesn't have to be bleeding edge AI, though of course, if it is, that's even better. Much more likely, of course, to get the tick from the panels that adjudicate these. But it's really about original to the company, an opportunity for the company to generate more income, become more profitable, create more jobs. That's what it's really about.
Okay, so I'm gonna frame a challenge here for you, and I'm gonna see how you're gonna do on this challenge. So, as an organisation, we've got lots of data, but we've got no AI skills, but we don't have a new product or service. Help! How can you help?
Okay, that's actually quite easy. As a university, we love real-world data sets. So you could give those real-world data sets to myself, or to Matloob, or to Adnane, and we will take these data sets for you and the questions you haven't got answers for yet, and wrap this up as assignments, and we give them to our students. We're doing this very successfully now on one of our modules, and the organizations that partner with us on this, they love it, because it's 10, 20, 30 different pairs of eyes, different brains going in there and generating new and exciting answers.
Yeah, I get that, and sometimes just taking a completely different view of things gives you surprising results. I really do get that. Let's go back to the Suffolk Libraries project, which I thought was really interesting. But how do you know if an activity can be mapped to one or more of those emotional needs? How do you take that?
Okay, so that's the reason why we have my colleagues from Social Science and Humanities on the project. So Sarah and Abby are looking to get actual evidence that proves if you go to a book club or you sign up for some other form of activity in the library, that it does make you happier. It does actually make you healthier, and have that evidence base rather than it just being, well, we think it works, therefore we'll just tag all these activities and we'll hope that people feel better as a result of going to them. We're trying to get the evidence base to prove the work.
Yeah, I see that as vital, really. Otherwise, we've seen recently in times around COVID. In fact, let me just talk about COVID a bit. How the evidence has really helped us try to manage our way out of the situation, really. But for the COVID project, how will you be able to test the validity of results, or even explain the results?
Well, that's one of the reasons why Mahesh and colleagues and Aida and Federica are spending so much time looking at the blood samples, and also trying to come up with a stable protocol for generating the data, so that we rule out stupid things like the AI algorithms going in and going, oh, well, it's a COVID one. And you look at go, no, it's not a COVID one. You're just picking up something stupid, like the size of the image is different, or the staining is not the same. So we're trying to rule out stupidities like that. And go beyond into the
brilliant. I love ruling out stupidity. That's a story of my life. So thank you very much indeed.